In today's video, we're going to explore how ions are formed and understand why certain atoms are more likely to form ions than others. An ion, in simple terms, is a charged particle, which can either be a single atom like sodium ion, written as Na+, or a group of atoms that behave as a single charged unit, such as the hydroxide ion, written as OH-. As we've discussed in our previous video on electron structure, ions are produced when atoms gain or lose electrons in order to achieve a full outer electron shell, which makes them more stable, much like noble gases that naturally have complete outer shells. One of the helpful things about the periodic table is that the group number of an element indicates how many electrons are present in its outermost shell. For example, elements in group 1 have 1 electron in their outer shell, those in group 2 have 2, and so on. Now, for an atom to become stable, it must either lose or gain enough electrons to achieve a full outer shell. This process, however, requires energy. Atoms that only need to lose or gain 1 or 2 electrons require much less energy to do so and are therefore far more likely to form ions. This is why elements in groups 1 and 2, which only need to lose 1 or 2 electrons respectively, very easily become positive ions. Group 1 elements, also known as the alkali metals, lose a single electron to form 1+ ions, whereas group 2 elements lose 2 electrons to become 2+ ions. On the other hand, group 6 and group 7 elements tend to gain electrons. Group 6 gains 2 to become 2- ions, and group 7 only needs to gain 1 electron to become a 1- ion, such as a chloride or fluoride ion. However, atoms in groups 3, 4, and 5 would have to gain or lose 3 or more electrons in order to reach a stable configuration, and that requires significantly more energy, making it far less likely. As a result, these elements are rarely found forming ions in typical chemical reactions. Just like we can write chemical equations to describe reactions between atoms, we can also write specific equations to show the gain or loss of electrons during ion formation. For instance, when a sodium atom loses 1 electron to become a sodium ion, we write it as sodium atom forms sodium 1+ ion plus 1 electron. This shows that the electron has been lost and is now separate. Conversely, when an atom like chlorine gains an electron to become a chloride ion, we show it as chlorine atom plus 1 electron gives chloride 1- ion. This indicates that the electron has been added to the atom. The position of the electron in these equations is important. If the atom is losing electrons and becoming positively charged, the electron appears on the right side. If the atom is gaining electrons and becoming negatively charged, the electron is shown on the left side, joining the atom. Sometimes, atoms lose or gain more than 1 electron. For example, magnesium, which is in group 2, loses 2 electrons to become a magnesium 2+ ion. In this case, we write the equation as magnesium atom forms magnesium 2+ ion plus 2 electrons. On the flip side, if we consider an atom like oxygen from group 6, it gains 2 electrons to complete its shell, and we write oxygen atom plus 2 electrons gives oxygen 2- ion. These types of ionic changes are crucial to understanding how atoms interact and form compounds, especially in reactions between metals and nonmetals. And that's everything you need to know for now about how ions are made and why some atoms form them more easily than others. If this explanation helped you understand the topic better, don't forget to give the video a like and subscribe. We'll see you in the next lesson.